All right, yesterday we talked about finding the sums of finite arithmetic series. Today we're going to talk about geometric series. Again, these are just expressions formed by adding the terms of a geometric sequence. Remember, a geometric sequence is something where I have a common ratio. Things are being multiplied between each terms. So we have a different formula than the one we did yesterday. And for my finite geometric series, remember finite again means it's going to end, so there's not going to be a ... behind it. It is the formula S sub n equals A sub 1 times 1 minus r to the nth power over 1 minus r. And when we start looking at these, we're going to remember our sigma notation, just a reflection of that. My bottom term, like on our first example, the 1 is my starting term. The 10 is the ending term, or the number of terms I'm going to put together here. I'm going to be doing terms 1 through 10. And the sequence that I'm going to use is 4 times 3 to the I minus 1. And what is nice about this one versus the arithmetic one is I actually even need less things in here. Things I need to find before I can plug them into my formula. I kind of need to know what my ratio is, and I need to know what my A sub 1 is really the two things I need to know before I go in here, and then what term I'm looking for. And those can all be found within our within our summation or sigma notation or summation notation. So let's kind of look at this and break it apart. Remember when we did geometric sequences, my geometric sequence would be A sub 1 times my r to the n minus 1. So if you're given a sequence, you're automatically given the first term and your ratio in here. So when I go back and look at this, A sub 1 is going to be 4, and my r is 3. So once I know those, I can plug those into my sigma notation. I'm going to find the sum of the first 10 terms because that's what this is telling me here. And that's going to be my my first term, which we said was 4. And then I have 1 minus my r to the 10th power, because that's what my n is representing and what the terms I'm putting together. And then 1 minus 3. And honestly, I would type all this in my calculator because it's going to become a very large number. And I would get A sub 10. Even if I simplify the top part, I would have 4 times negative 59,048 divided by negative 2. And when I simplify all that out, my sum is 118,096. All right, so not too bad of a formula to use. It really just comes down to being able to read my sigma notation also. So on number 2, I have a sigma notation that says I'm doing terms 1 through 8. And my sequence is negative 16 times 1/2 to the I minus 1 power. So when I start looking at that, I can tell you that my A sub 1 is 16, negative 16. My R is 1/2, just because those again are the same as in my formula. And then I can plug them into my summation formula. So I want to do sums of 1 through 8. And I'm going to do negative 16. I'm using this formula right here. 1 minus 1/2 to the 8 minus 1. Oops, sorry, I don't need the minus 1. Got a little carried away there. Just to the 8th power over 1 minus 1/2. And I would probably put parentheses around those as I go through. When I work those in my calculator, I'm going to get negative 16 times 0.9961 divided by 0.5. And all of that is going to come out to be about negative 31.88. All right, let's look at the bottom 4 problems. So that's if you have sigma notation. All right. On the last 4, or the last 2, I have a sequence. So I'm going to give you the 2 formulas again that we have. My summation one is S sub n equals my first term times 1 minus r to the nth power over 1 minus r. And my general, to find the sequence or any nth term, that is a sub 1 times r to the n minus 1. So on number 3, it asked me to find the first 7 terms. So I know that my n is going to be 7. I know my a sub 1 is 6. And I can find my ratio by what I'm multiplying by between here. 6 times 4 is 24. 24 times 4 is 96, and 96 times 4 is 387. So my ratio is 4. And now I'm going to plug that into my S sub n. So let's do that. I'm going to find the summation of the first 7 terms. And I'm going to do 6 times 1 minus my ratio of 4 to the 7th power over 1 minus 4. And when I simplify that, I get 6 over negative 16,383 divided by negative 3. And that becomes 32,766. Okay. All right. The last one. We're going to find our first 11 terms of the sequence. So my n is going to equal 11. My a sub 1 is negative 3. And notice negative 3 to negative 15 is going by 5, being multiplied by 5. Negative 15 times 5 is negative 75, and negative 75 times 5 is negative 375. So my ratio is 5. And we can plug that into our formula. So the summation of the first 11 terms is going to equal my first term of negative 3 times 1 minus my ratio of 5 to the 11th power. It's going to be a big number. And 1 minus 5. And when I start simplifying this, I would get negative 3 times 48 million 828,124 divided by negative 4. When I divide that out and multiply it by negative 3, I'm going to end up with the summation of the first 11 terms would be negative 36,621,093. So something you probably don't want to spend all day adding onto your calculator. It'd be much easier to find the sum. All right, I hope this works for you. If you need any help, come see me in the office hours.